This video is going to be on graphing exponential functions using a table. Example 1 is the function f of x, or y, equals the initial value of 4 times 2 raised to the x power plus 1. What you're going to do is you're going to substitute in the values of x and solve using order of operations to find the f of x value or the y value. Sometimes I set up my table like this so that you can do the work in the middle when it breaks down, once you break it down far enough. So I'm going to go ahead and substitute this in. So I'm going to have 4 times 2 raised to the negative third power plus 1. There's a law of exponents that says anything raised to the negative power gets put on the bottom of the fraction. So this is really 2 over 1. So we transfer it to 1 over 2 to the third. That's in parentheses, multiplied by 4, and then when we solve that, it's going to be added 1. So order of operations says to do exponents first. So I'm going to have 1 over 2 to the third power means 2 times 2 times 2, which gives you 8. Keep that in parentheses with the 4 on the outside, then plus 1. So now I'm going to solve 4 times 1, 8. So if I go 4 times 1 is 4 over 8 plus 1. 4 eighths is really 1/2 plus 1. So when it gets down to that part, that's when I'm going to put it in the table. So 1 plus 1/2 is really 1.5 or 1.5. Now I'm going to do the same thing for every value. I'm going to go ahead and just do it and then put in my -2 and -1 values here. When I substituted in -2 for x, I got a y value of 2. And when I substituted in -1 for x, I got a y value of 3. Now we're going to go ahead and substitute 0. So I'm going to have 4 times 2 to the 0th power plus 1. There's another law of exponent that says anything to the 0th power is 1. So 2 to the 0th power is 1. So I'm going to have 1 times 4 plus 1. Well, 1 times 4 is 4 plus 1 is 5. I'm going to go ahead and do the remaining 2 values. When making a graph, consider your scale. Your x scale needs to be the same all the way through. So I'm going to go by ones, but I'm skipping a line. So 1, 3, and 5, and then -1, -3, -5 along my x. My y, my highest value is 33. So I need to go by more than ones on my y-axis. So I'm going to go, each one is going to be 2. So if this is 2, the second line is 4, the third line is 6. 8, 10. And then going downwards, it's going to be -2, -4, -6, -8. And then I'm just going to plot my points. So my first point is -3, 1.5. So that's going to be about right here. Then I have -2, 2, which is going to be right here. -1, 3, which is right here. It's slowly increasing, not in a linear pattern either. 0, 5 is right here. 1, 9 is right here. And then 2, 33 is up here if you kept counting. And so I'm going to go ahead and make my smooth curve. Realizes this right here means it's going to get close to 1, but actually never ever touch 1. And then it's going up pretty rapidly. It never flattens straight, but it almost looks like it is. And so this is an exponential growth graph, which you will need later on this unit. Example 2 is f of x or y equals the initial value of 4, a common ratio of 1/2 raised to the x power. When you have a fraction for a rate, values of x are easier if they're negative because then it's a whole number that you're multiplying. But you still want to have some negative and some positive numbers as well as 0. So I'm going to go ahead and substitute -3 in so that you can see how it works. And I'll substitute 0 and 2, and then the other ones I'm just going to do, and you can check your work if you solve them. So I'm going to have 4 times 1/2 raised to the -3rd power. Well, when you have a negative power, you have to flip your symbol or your fraction and then raise it to the positive power. So then this changes, 2/1 just changes to 2. So then 2 to the 3rd power is 2 times 2 times 2, which is 8, times 4. So 4 times 8 is 32. Now I'm going to substitute 0 for x. So I'm going to have 4 times 1/2 raised to the 0th. Well, anything raised to the 0th power is 1. So 4 times 1 is 4. The last one I'm going to substitute in is 2. So we're going to have 4 times 1/2 raised to the 2nd power. So we have 1/4 times 4. Well, 4 times 1/4 is 1. And if you look and apply the common ratio that you learned in sequences, this one is a lot easier than example 1 was because you don't have that +1 on the end. But if you look, what do you have to do to go from 32 to 16? You divide by 2. Well, dividing by 2 is really the same thing as multiplying by 1/2. And the same thing, from 16 to 8, you divide by 2. 8 to 4, you divide by 2. 4 to 2, divide by 2. So you can check your work on the ones that don't have a plus something at the end. Because that way, you know and you can apply previous lessons to it. So now we're going to go ahead and graph this. So the first thing we're going to do is create our scales. Again, we're going to go by 1 on the x-axis. And we're going to go by 2s on the y-axis. And same thing below. So now I'm going to go ahead and plot my points. So my first point is -3, 32, which is up here. Then I have -2, 16. -1, 8, 0, 4, 1, 2, and 2, 1. And the line is approaching 0 because it's +0 at the end. And so it's a smooth curve going downward, approaching 0, but never touching 0. This is known as exponential decay. The next video in the series will be on exponential growth and exponential decay and what makes it decay and what makes it growth. On the next slide, there'll be a couple problems for you to try. The first problem I would like you to try is an exponential decay problem with the f of x equaling the initial value of 9 with a rate of 1/3 to the x power plus 2. In example 2, the function f of x equaling an initial value of 1 with a rate of 3 to the x power. Thanks for watching.